Hello student, good morning to all of you. Today we will study about metal and non-metal. This is chapter 3 and from class 10. Okay, and I will give you the full concept of this chapter as per as given your NCERT syllabus. Okay, so in before this chapter I have already give you the introduction of the metal and non-metal, and I have taught you about the physical properties of metals. Today we will again see about the physical properties of metal in short. For example, we have already studied properties of metal, that is metal is hard and have a high tensile strength, and generally metals are solid at room temperature, metals are sonorous, metals are good conductor of heat and electricity, metals are malleable and it can be beaten into a thin sheet. Metal also has ductile nature. Due to this nature, metals can be drawn into a thin wire. Okay. Next, metal has high melting and boiling point. For example, there are so many metals you will find in periodic table, and exception you will see about cesium and gallium. Okay, this cesium and gallium has no high melting and boiling point. Okay, metals generally dense, except you will find in alkali metal, that is osmium, that is highest density, and lithium that is least density. Okay, metals are luster, and metals are silvery gray in color except gold and copper. Okay, again we have already studied about the physical properties of non-metal. As we know, non-metals occurs as solid, liquid and gases at room temperatures. Okay, non-metals are brittle, non-metals are non-malleable, non-metals are non-ductile, non-metals are non-sonorous, and non-metals are bad conductor of heat and electricity. And also we have seen exception is physical properties of metal and non-metal. As we know, alkali metals sodium, potassium, lithium can be cut using a knife. Generally we have seen the metals are solid, but these are soft metal. Due to this properties, sodium, potassium, lithium, we can cut by using a knife. Okay, and second exception here you are seeing about mercury. Students, mercury is a liquid metals. Okay, third, lead and mercury are poor conductor of heat. Okay, next exception, mercury expands significantly for the slightest change in temperature. When you change a small temperature, then mercury expand fast. Okay, gallium and cesium have a very low melting point, we have also seen, and iodine is a non-metal but it has a lustrous. Okay, you will find lustrous characteristics in iodine. Okay, generally we find luster characteristics in metal, but here we are finding in iodine, that is non-metal. And also one more exception, that is graphite. As you know, graphite is non-metal, however it conduct electricity. It means this is exceptional case. And next, diamond conduct heat and has a very high melting point. Okay, diamond is also examples of non-metal. Okay, but it conduct heats. Okay, and its melting point is very high. So these are the main exceptions and in periodic table, and especially in metals and non-metals. Okay, now today we will study about the chemical properties of metal. And first of all, alkali metal, that is you can see in first period in the periodic table. Okay, all the metals are called alkali metals, and here we are studying among that metals, lithium, sodium and potassium. They react vigorously with water and oxygen or air. Remember it, lithium, sodium, potassium comes from alkali metals group, and they react vigorously with water and oxygen or air. Okay, and also second you can remember alkaline earth metal, that is magnesium. Magnesium react with hot water. Okay, magnesium has properties that it reacts with hot water, where aluminum, iron and zinc react with steam. Okay, and copper, Ag, Pt, Au do not react with water or dilute acid. As you know that copper, Ag, platinum, Au, these are the least reactive metal. Okay, and generally copper, Ag, Pt and Au do not react with water and dilute acid. Okay, no problem. These are the chemical properties of metals. And next, as you know that when metal react with oxygen, we get metal oxide, and nature of metal oxide, this is basic. Sodium and potassium are kept in immersed in kerosene. As you know now that sodium and potassium are very reactive metal. Okay, and it react fast with air, and it can catch fire. So for safety we kept sodium and potassium in kerosene oil. Okay, for example, you are seeing the reaction potassium plus oxygen gives K2O, and you are seeing the reaction is vigorous reaction. This reaction is very fast. Okay, it happens very fast. Next, magnesium, aluminum, zinc, Pb react. Magnesium, aluminum, zinc and lead react slowly with air and form a protective layer that prevents corrosion. Okay, at last we will study about corrosion. Okay, when metal react with air and form a protective layer, okay, and we study in corrosion that corrosion prevents. Okay, corrosion, for example, we have a study about rust. Okay, it means corrosion means what? Ki metal react with air. Okay, and next, magnesium react with oxygen gives magnesium oxide, and in the same way aluminum react with oxygen and form aluminum oxide. Okay, so you will remember that magnesium, aluminum, zinc, lead react slowly with air and form a protective layer that prevents corrosion. And last silver, platinum and gold don't burn or react with air due to least reactive nature. These are the chemical properties of metals. Okay, now we will study about the basic oxides of metal. Some metallic oxide get dissolved in water and form alkali. For example, you are seeing sodium oxide react with water and form alkali. NaOH, basic base, these are the alkali. Okay, and their aqueous solution turns red litmus to blue. As you know na, the characteristics of litmus paper, in aqueous solution we get red litmus paper color to blue, and in acidic solution we get blue litmus paper into red color. Okay, so sodium oxide plus water gives sodium hydroxide, and potassium oxide plus water gives potassium hydroxide. These are the basic nature. Okay, that's why its aqueous solution turns red litmus paper into blue color. Okay, now we are seeing the amphoteric oxides of metal. Students, those metals react with both acid as well as bases. Okay, the amphoteric oxides are metal oxide which react with both acids as well as bases to form a salt and water. For example, Al2O3, aluminum oxide, zinc oxide, lead oxide, SN oxide, okay, stannous oxide. These are the example. These are the amphoteric oxides of metals, because these oxides of metal reacts acid as well as bases. For example, you are seeing here aluminum oxide react with hydrochloric acid, and also aluminum oxide react with sodium hydroxide. And in the same way we can see about zinc oxide also react with hydrochloric acid, and zinc oxide also react with sodium hydroxide. So here we are seeing the oxides of metals react acid as well as bases due to this characteristics. These are called amphoteric oxides. Okay, these are called amphoteric oxides of metals. Now we must remember about the reactivity series of all the metals and some non-metals also. Okay, we will find here non-metals. It means about we will study about hydrogen basically, and rest all elements will be metals. Okay, here we are saying symbol K for potassium. Potassium is very highly reactive metals. Okay, and then barium, then calcium, then sodium. Okay, you must remember this reactivity series. Okay, when you remember this reactivity series, you are able you can be able to judge the reaction Okay, especially you will find you can judge in displacement reactions in especially in your 10th standard. So remember this series. Okay, and next after sodium you will find magnesium, aluminum, zinc, iron, nickel, Sn, Pb, and here I have written the name. You can remember Mg for magnesium, L for aluminum, zinc for Zn for zinc, Fe for iron, Ni for nickel, okay, and Sn for tin, Pb for lead. Okay, now next hydrogen, H for hydrogen, Cu copper, Hg mercury, Ag silver, Au gold, and Pt platinum. These are all the metal I have written in increasing order of their strength. Okay, so most highly reactive metal, that is sodium. You must remember in your mind. Okay, and the least reactive metal, that is Pt, Au, Ag. Okay, these three least reactive metals are also called noble metal. Okay, now see reaction of metal with water or steam. As you know, when metal react with water, you can get metal hydroxide or metal oxide plus hydrogen. Okay, for example, sodium react with water to gives NaOH, and calcium react with water to give COH ka whole 2, and also aluminum react with water to give aluminum oxide. It means what? When metal react with water, we can get either metal hydroxide or metal oxide plus hydrogen gas. Okay, for example, you can remember such reaction. Okay, when sodium react with water, that is cold water, calcium react with also cold water, but magnesium react with hot water, aluminum react with steam, okay, and zinc react with also steam, and iron can also react with steam, that is hot water. Okay, and this is hot water, and these are the metal react with steam, and these are the metal react with cold water. Then metal react with water, and we are getting metal hydroxide or metal oxide plus hydrogen gas. Okay, now next reaction of metal with acid. When metal react with dilute acid, we get salt or hydrogen gas. For example, sodium plus hydrochloric acid gives NaCl, that is salt and hydrogen gas. Other example, you can see potassium plus H2SO4, hydrogen sulfate, that is sulfuric acid, we get potassium sulfate plus hydrogen gas. And remember that magnesium and Mn react with very dilute nitric acid to liberate hydrogen gas. You can see here reactions, magnesium plus HNO3 gives MgNO3 whole twice plus hydrogen, and also we can see manganese plus react with HNO3 and get MnNO3 whole 2, okay, plus hydrogen gas. So we are seeing here metal, when metal react with dilute acid, we get salt and hydrogen gas, and we have remembered that in your mind that magnesium Mn react very dilute nitric acid and to liberate hydrogen gas. So this is very important reactions for examination point of view. And next we can talk about displacement reaction, because we have already studied reactivity series. Okay, if you have remember reactivity series, you can judge all the displacement reaction. Displacement reactions means a more reactive element displaces a less reactive element from its compound or solution. Now question is arising, how do metal react with solution of other metal salt? Okay, so as you know, metal A plus salt of metal B means what? Salt of metal A plus metal B. It means one metal is trying to displace other metal from their salt solution. For example, iron react with copper sulfate, and here we know that iron is most reactive with copper. So iron can displace copper from their copper sulfate solution, and it can form iron sulfate, and copper can be side, okay, because due to least reactive. Okay, now second example, you are seeing here copper react with silver nitrate and gives copper nitrate solution. It means here silver is least reactive and copper is more reactive comparison with silver. So copper can displace silver from silver nitrate solution and form copper nitrate. Okay. Now reaction of metal with bases, you remember that when base react with metal also form salt and hydrogen. Okay. Here example, sodium hydroxide react with zinc and we are getting here salt. Okay, sodium zincate and hydrogen. Now second example, sodium hydroxide react with aluminum and water and form sodium aluminate plus hydrogen gas. So always remember when base react with metal to form salt and hydrogen. Now uses of displacement reaction, where we use displacement reaction. So dear student, by displacement reaction we extract the metal, or we can say in case of extraction of metals we use displacement reaction. In manufacturing of steel we use displacement reaction. For example, thermite reaction, that is aluminum react with Fe2O3 and get Al2O3 plus molten iron. The thermite reaction is used in welding for railway track, cracked machine part, etc. So this reaction is very important. Okay, this is thermite reaction. Understand? When aluminum react with Fe2O3 ferric oxide, we get aluminum oxide plus molten iron. Okay, and this reaction we use in welding of railway track or crack machines parts, etc. Okay. Now occurrence of metals. Most of the element, especially metals, occur in the nature in the combined state with other element. All these compounds of metal are known as minerals, but out of them only a few are viable sources of that metal. Such sources are called ores. Dear student, natural occurring substance also is known as mineral, and those substance in which there is a possibility for getting metals, and metals or metals and different types of metallic oxide, all these things, these are called ores. Okay, it means we can extract any metals from their particular ores. Okay, and for remember AuPt exists in the native or free state in earth crust. So remember, this is very important points, and generally we get metals from their particular ore. For example, aluminum, we can get aluminum by their bauxite ore. Okay, iron, we can get iron from their hematite or magnetite ores, etc. Okay, now you can see the extraction of metals. We are here we will discuss about the steps. Okay, ores, you are seeing here about ores, classification of ores, that is metal of high reactivity, metals of medium reactivity and metals of less reactivity. In metals of high reactivity, remember the process electrolysis of molten ores and we get pure metal. Okay, in short we have to study in class 10 this extraction of metals. Okay, it means we are just like now we are studying in class 10 just concentration word. Okay, in extraction of metals we will not go deeply in class 10 about extraction of metal, but when we study about metal extraction of metal in detail, then we will study in class 12. Okay, so remember here metals of highly reactive, if we process extraction of high reactivity metal, then we follow the process of electrolysis of molten ore and we get pure metal. Metals of medium reactivity, we will see two ways, one for carbonate ores and second for sulfide ores. When we get carbonate ores of particular metals, then we will do process calcination, and for sulfide ores process is roasting. Okay, and after calcination and roasting we find the oxides of metal, and then reduction, we will apply the process of reduction from oxides of metal to metal, and finally refining process. After refining we can get pure metal. Okay, and third is very extraction of metal for very low reactivity, and we will follow here process electrolysis of molten ores, then pure metal, and electrolysis of molten ores, and finally pure metal. So these are steps for extraction of metal from their particular ores. Remember, this is metals for high reactivity, these steps. This second step, metals of medium reactivity, and third step, metals of very low reactivity. Okay. Now remember, metals of high reactivity, in which sodium, potassium, magnesium, aluminum include. Metals of medium reactivity, in which iron, zinc, Pb, Sn includes, and metals of low reactivity, copper, Ag or and Hg include. Now next is roasting. Okay, the roasting what? To convert sulfide ores into oxide on heating strongly in the presence of excess air. As you know na, ki roasting means what? Heating. So here sulfide ores, especially we will follow the process of roasting for sulfide ores. Okay, when sulfide ores strongly heating in the presence of what? Oxygen. Okay, roasting process will done in the presence of oxygen. So it converts sulfide ores into oxide on heating strongly in the presence of excess air. Okay, and it also removes volatile impurities. Okay, volatile impurities means those substances which are easily vaporized. Okay, getting heat. Okay, for example, zinc sulfide react with excess supply of oxygen, and we get zinc oxide. Okay, and from here by the reduction process we can get zinc and also sulfur dioxides. Okay, now second process is calcination. So it converts carbonate and hydrated ores into oxide on heating strongly in the presence of limited air. Why limited air? Because oxygen is already contained in in particular ores. So limit supply of oxygen or absence of oxygen is required here. Okay, so here you are seeing that zinc carbonate react with heat. I mean when we gave the heat to zinc carbonate, it gives zinc oxide plus carbon dioxide. Okay, these are all the reactions are endothermic reactions. Okay, and also last reaction was also endothermic reaction. Okay, so zinc carbonate gives zinc oxide, and from here we can get zinc. Calcium carbonate gives calcium oxide. Okay, aluminum, hydrated aluminum oxide gives aluminum oxide, and hydrated iron oxide gives iron oxide. In here after reduction we can get particular metals. Okay, in their pure state. Now extraction metal low, extracting metals low in reactivity series. So by self reduction, remember, by process of self reduction, when the sulfide ores of less electropositive metal like Hg, Pb, copper, etc. are heated in air, a part of the ores gets converted to oxide, which then react with the remaining sulfide ores to give the crude metal and sulfur dioxide. In this process, no external reducing agent is used. So remember, extracting metal low in reactivity series, by the help of self reduction process we can get. Okay. Also you are seeing the example HGS, that is cinnabar. Okay, this is important ores of mercury. Okay, react with oxygen gives crude metal, that is crude metal, that is HgO, mercurous oxide, and sulfur dioxide, and this HgO heated and we get mercury. Okay, it means here reduction is happening and we get oxygen. In the same way, copper pyrite, this is the ores of copper. Okay, and we can get copper from this particular ores of copper, that is copper pyrites. Okay, and also here cuprous oxide, this is also very good important, we can say important ores of copper. Also we can get copper. Okay, this is cuprous sulfide react with the oxygen to get copper oxide and copper oxide. Sorry, this is not a ores, we can this is the byproduct of copper pyrite. Okay, this is the byproduct of copper pyrite, and by the help of copper oxide we get copper. It means this is reduction process is happening here. And second is galena. Okay, this is the important ores of what? Lead. Okay, this is the important ores of lead. Okay, and lead oxide react with oxygen, lead sulfide galena, that is lead sulfide react with oxygen to get lead oxide, and lead oxide react again with lead sulfide to gives Pb, that is lead. Also here reduction process is happening. Okay, now extraction metal in the middle of the reactivity series we have already studied smelting. Okay, it involves heating the roasted or calcinated ores to high temperature with a suitable reducing agent. The crude metal is obtained in its molten state. For example, Fe2O3 plus carbon gives Fe plus CO2. Now, aluminiothermic reaction, also known as Goldsmith reaction, is highly exothermic reaction in which metal oxides usually of iron and chromium are heated to a high temperature with aluminum. You can see reaction Fe2O3 plus aluminum gives Al2O3 plus iron plus heat. Now, Cr2O3 react with aluminum to gives Al2O3 plus chromium. Okay. Now, extraction of metal towards the top of the reactivity stage by the process electrolytic process, and this is very important process, that this is Down's process. Okay, this question always come in your examination. Okay, so in Down process molten sodium chloride is electrolyzed in a special apparatus, and at cathode we get reduction. Reduction, it means gain of electron, as you know, reduction, and loss of electron, that is oxidation. Here you are seeing that sodium ion get electron and deposit at cathode as a sodium metal. Okay, so this is this process is happening at cathode, and at anode oxidation is happening. Here at anode chlorine gas is formed. Okay, chlorine gas is liberated. Okay, so this process is known as Down process. Second is Hall's process. The mixture of molten alumina and fluoride solvent, usually cryolite Na3AlF6, is electrolyzed, and we get aluminum at cathode after reduction process. Okay, and at anode we get see oxygen gas is liberated. Okay, enrichment of ores, it means the removal of impurities or gangue from ore through various physical and chemical process. The technique used for a particular ores depend on the difference in the properties of ore and the gangue. Okay, so remember this point, very important. Or also you can say concentration of ores, it means removal of impurities or gangue from the particular ores through the various physical and chemical process. Also in detail we will study in higher classes. Okay. Now, refining of metals. So, refining of metals, removing impurities or gangue from crude metal, it is the last step in metallurgy, and it is based on the difference between the properties of metal and gangue. Okay. Now, electrolytic refining, remember metal like copper, zinc, nickel, silver, tin, gold, etc. refined electrolytically. At anode, impure or crude metal. At cathode, a thin strip of pure metal, electrolyte, aqueous solution of metal salt. And remember, at anode, impure or crude metal, we will find cathode at a thin strip of pure metal, we will take electrolyte, aqueous solution of metal salt will take, and from anode oxidation, and at cathode reduction process happening. Okay. From anode, metal ion is released into the solution, and at cathode the equivalent amount of metal from solution is deposited, and impurities deposited at the bottom of the anode. This is the electrolytic refining process. Remember, this is very important. Now, concept of alloy. Alloy are homogeneous mixture of metal with other metal or non-metal. Alloy formation enhance the desirable properties of material such as hardness, tensile strength, and resistance to corrosion. For example, we can remember brass, bronze, soldier, amalgam. These are the alloy. Brass is the alloy of copper and zinc. Bronze, this is the alloy of copper and tin. Soldier, this is an alloy of lead or tin, and amalgam, this is an alloy of mercury and other metal. Okay. Now come to the point of corrosion. So gradual deterioration of the material, usually a metal, by the action of moisture, air or chemicals in the surrounding environment. Okay, this is corrosion. For example, you can see rusting. Okay. Gradually metal react with moisture, air or chemicals. This is known as corrosion. For example, you have a study about metal, then iron react with air and gives hydrated iron oxide. This is the rust. Okay, this is the formula of rusting of iron. Also you can see the corrosion of copper. Copper react with water, carbon dioxide and get copper carbonate plus in dot copper hydroxide in green color. Okay, CuCO3 dot CuH ka plus CuH ka whole 2. Here we will find plus sign. Okay, and also Ag react with H2S and form Ag2S plus hydrogen. Now prevention of corrosion. So by the applying this process, you can prevent corrosion. First, coating with paints or oil or grease. Second, alloying, and third, galvanization. Coating with paints or oil or grease. Application of paint or oil or grease on metal surface keep out air and moisture. In alloying process, alloy metal is more resistant to corrosion. Example, stainless steel. Galvanization, this is a process of coating molten zinc or iron article. Zinc form a protective layer and prevents corrosion. Now next process, electroplating. It is a method of coating of one metal with another by use of electric current. This method not only lends protection but also leads protection but also enhance the metallic appearance. Example, silver plating, nickel plating, etc. Or last process is Sakadi facial protection. Magnesium is more reactive than iron. When it is coated on the article made of iron or steel, it acts as a cathode, undergoes reaction instead of iron and protect the article. So these are 5 processes very important, okay, for prevention of corrosion. Okay, now electronic configuration, you have remembered lithium 21, sodium 281, potassium 2881, rubidium 28181. Okay, element beryllium, you can remember electronic configuration 22, magnesium 282, calcium 2882, strontium 28182. Now question is, how do metal and non-metal react? So metal loss valence electron and form cation, and non-metal gain those electron in their valence shell and form an ion. This is first step. The cation and ion are attracted to each other by the strong electrostatic force, thus forming an ionic bond. For example, in calcium chloride, the ionic bond is formed by the positively charged calcium and chlorine ion, and calcium atom loses 2 electron and attains the electronic configuration of the nearest noble gas, argon, and by doing so it gains a net charge plus 2, and this is the process how the metals and non-metals react. Okay, you can see here in picture also. Okay, metal release 2 electrons, you are seeing na, from outermost shell, and here chlorine gain electron, okay, and form compound CaCl2. Now ionic compound, what is ionic compound? The electrostatic attraction between the positively charged ions hold the compound together. This is known as ionic compound. For example, MgCl2, CaO, MgO, NaCl, these are the ionic compounds. Now properties of ionic compounds. Ionic compounds are usually crystalline solids, have high melting and boiling point, and conduct electricity when in aqueous solution, and when melted are mostly soluble in water and polar solvent. Remember, this is important. Physical nature, ionic solid usually exist in regular well defined crystal structure. Electronic conduction of ionic compound. The ionic compound conduct electricity in molten or aqueous state. When ion become free and act as a charge carrier in solid form, ions are strongly held by the electrostatic force of attraction and not free to move, hence do not conduct electricity. Very important. Okay, why ionic compound not conduct electricity? Very important questions. But in their molten or aqueous state, it can conduct electricity. Okay, this is in solid state and this is molten and aqueous solution. You are finding the proper sufficient place to move for moving ions. Okay, that's why in this state ionic compound conduct electricity. Okay, for example, ionic compounds such as CuCl2 doesn't conduct electricity when solid and conduct electricity, but when dissolved in water or in molten state. Okay. Now melting and boiling point of ionic compound. So in ionic compound, the strong electrostatic force between ion require a high amount of energy to break. Thus, melting and boiling point of ionic compounds is usually very high. Solubility of ionic compounds. The most ionic compounds are soluble in water due to the separation of ion by water. This occurs due to the polar nature of water. For example, NaCl is a 3D salt crystal composed of Na plus and Cl minus ion bound together through electrostatic force of attraction. Okay, you will remember this point also. When a crystal of NaCl comes into contact with water, the partial positive charge ends of water molecule interact with chlorine ion, while the negatively charged end of the water molecule interacts with a sodium ion, and this ion dipole interaction between ion and water molecule assists in the breaking of a strong electrostatic force of attraction within the crystal and ultimately in the solubility of crystals. So also remember these points. Okay, you can see in a structure, this is the structure of NaCl crystal. Okay, NaCl in water, and this is solid in solid form. Okay, this is in aqueous form and this is in solid form. Okay, dear students, I hope this is only uh, just like a revision lecture. Okay, and really it will help in your examination. Okay, thank you.